the last few LUGs, 2 LUGs actually, I've kind of spoken very much about what we were going to do and what we intended to do over the next year. And so this year I thought I would focus a bit more on what we've done and kind of give you an update of as it says, where we are now, and focus a bit on some of the features and that we've developed. And just to be clear, so that everyone, I'm sure everyone does know, this test infrastructure that I'm referring to is the test infrastructure that we use for the tree. And so all of the development that happens and all of the releases go out are using this infrastructure. So let me begin. Brief agenda. I want to talk a little bit about Intel values, or one in particular. I want to just kind of refresh what our aims were when we started WAM Cloud, and then look at what we've done. And to be honest, I won't get to where we're going because I'll run out of time. But if I do, I will. So Intel values. Now, the last 2 years, I quoted some value on quality, either from Brent or Eric. And so this year, I kind of thought I'd try and do the same thing with the new boss man, but slightly harder because I haven't had a coffee or a beer with Paul Ottolini yet, but you never know. But one thing I did want to pass on was during the WAM Cloud Intel merger, we did a bunch of training as we were kind of taken on board, and in one of those bits of training that wasn't to do with quality, wasn't to do with test, Paul Ottolini actually listed that verification and validation was a key value that he was proud of at Intel. And I thought for the CEO of such a large organization to list something so specific was really quite a good indicator that at least from my particular, or actually all of our interest in the quality of Lustre, that it had landed in a really quite good place. And listening to the value that the commercial guys placed earlier on, reliability and stability, etc. I was actually quite amazed that this was something that was mentioned to everybody who joins Intel. This wasn't a software or anything other than a general Intel intro, and yet verification and validation were the words he used were worthy of being mentioned. So I thought that was quite key. So a little snippet. Now, what were our aims? I wrote this on most of this deck on the way back from Beijing, and I was trying to work out what our aims were. What seems like a long time ago now when we started WAM Cloud. So I thought what I'd do is I'd look up the abstract that I sent to Steve Sims before LUG 2011, I guess, because it might give me ideas. And what I actually decided was that we could just take the words straight off the abstract. And I hate reading slides, but I'm going to read them. We said, and our goals were to create a consistent, repeatable test processes, to maximize the value of the distributed community testing required by the large test matrix, which is much larger now than it was then, show how community testing can be consistent enough to allow for process improvement whilst being flexible enough to enable each partner to operate independently, that we would build a component-based approach that allows considerable flexibility in the test environment whilst providing the closed-loop test processes required by any high-quality software product, and finally, that we would show how the test results can become part of the landing collateral for a patch. And those are the words taken. I've chopped the ends off the sentences, but those are unmodified what we sent to Steve as our kind of goals back in 2011. So I think we've actually done pretty well on that. The last one we could be doing better, and we can obviously improve everything. But that's what we were doing. So what have we done? Well, we've done quite a lot, I think. And we've done repeatability, and I'm going to dive into these. Distributed. We've got a distributed network. It's flexible. It allows independent testing, and we have actually ended up with a relatively component-based approach. So if we begin on each of those, so we have now a bunch of a completely cooperative infrastructure where we have test facilities in all of these places. The New Mexico one, I will be honest, is is on the verge of coming online. But we have all these things. They operate completely autonomously, ignoring Livermore, and I'll come to that, completely autonomously, and the work as we require it, as we do reviews and we do head and master testing, is shared out. So as I say, they just share the work, and some of them work independently. They all provide, they're all different. They all provide different attributes. And then we're able to do additional scale tests at Livermore on Hyperion, and that's manually. It's actually done by Cliff White. I don't know whether any of you know Cliff, but although he does that manually, the results all come back to Malou. And there's the man. Occasionally, Livermore, it's not big enough, it's not powerful enough, so we fire up Oleg's basement. And we do actually, and while I say that tongue-in-cheek, we have attached Oleg's basement to the infrastructure, and in a way it's just indicative of how we can take things and tag them on. I don't know whether it's truly a cloud, but we can, if there's things that can do test, we can make use of it and apply it to this big community thing that we're building. So flexible. So the test systems can be, as far as I found out, and I'm 2.5 years into the Lustre road trip. Test systems can be anything that supports Lustre. I'll say anything that anyone's allowed us to use, we have made use of. And the test requirements, when a review comes in, or we land something on master, or actually something requests something, the test requirements will guide the test to the correct location. So, OpenSFS NRE work will utilize the Indiana cluster, and in fact, basically only NRE work goes there. Although the other clusters will help out if Indiana can't do it. Large LUN testing, ULISH enables us to do that. And the larger clusters that we've now got in DuPont, and we'll soon have a pretty significant cluster in New Mexico. So if we need to do large LUN testing, the system will just guide it there. And we can also test single builds. So master reviews, when you do a landing on master, that's generally tested for DNE at OpenSFS, but the other testing for, non-DNE, LDiskFS, other things happen in other places. And the other thing that we've built on is just not to look at Lustre. So E2FS progs is now tested against Lustre. The Lustre manual, which Richard is going to talk about in a minute, when you put a change in for that for review, we actually at least build the manual. We'll work on reading it at some point in the future. And the HSM guys, we're doing some HSM testing at the moment, and we'll be able to set up clusters with the requirements for HSM and guide it there. And the key thing we're aiming for is that every change that occurs, we have some form of verification process that can verify it, I guess. Moving on, so I said consistent. The real word is repeatable. The clusters are, and the location is very, very repeatable, and the developers are agnostic to the location of the test. The test may occur at many sites, and as far as I've ever found, the results have always been treated by the developers equally. So no one's ever rejected a result because of where it was tested, which machine it was tested on. So they don't care, although they know, and I'm sure they would care if it wasn't giving them repeatable results. And one way we do that is that we do a completely new purpose-built cluster for every test session. So we do a ground-up install of the OS and Lustre, and the file systems. If we detect bad state during test, we completely rebuild the cluster from the metal up. And just recently, we're recording the version of all the components, and this may one day, this is just good practice, really. We're recording the version of all of the system components for every test, which means that we could historically rebuild any test. If we needed to, we could rebuild any system that the tests were carried out on. That we can't do automatically, but we'd have all the information at hand to do it if we ever needed to. Need some water. So looking to, those are the first 4 of those little round circles. So moving to the components, we wanted to aim for something that was, that was very flexible and allowed us to kind of mix and match and build tests kind of Lego fashion. So the things that we do have, we can do virtual InfiniBand, and I'm going to talk on some of these, and this isn't an exhaustive list, this is the kind of newer ones. That's too small for me to see. We're going to do, virtual InfiniBand, stutter testing, which I'll come on to, developer testing, which I spoke about last year, upgrade and downgrade testing, interoperability testing, failover, mixed nodes, and optional testing, which I will talk about. So the first one of those, which is really, really live actually, Frank Heckus is almost got this live this week, and I think by the time we go home, hopefully will. So Frank Heckus, who many of you will know, has been working closely with Mellanox to roll out virtual InfiniBand. It's still, he's so much chasing them that we're still using release candidate Mellanox code, I believe, but we are, we're rolling it out. And one of the issues that we've had, not an issue, but one of the realities is that in order to have enough clusters to carry out the amount of testing that we need to do, and every patch that gets pushed uses about 8 or 9 hours of cluster time. In order to do that, we've made extensive use of virtual machines. And the downside of that, which we've always been aware of, and we've always been very careful to carry out InfiniBand testing, separately and consistently, is that most of the testing happens on TCP, although it seems that TCP might be more popular than I imagined when I wrote this slide. And it would be nice if we could carry out more of that testing on InfiniBand. So the advantage of virtual InfiniBand is that we can have virtual clusters and we can test on InfiniBand at the same time. And in actual fact, we'll be able to, and we have the capability to mix physical and virtual nodes, so we can have physical servers and build large banks of virtual clusters. I still don't believe it's a replacement for real InfiniBand, but I think it's a very good analogy. I think more testing on InfiniBand is better, but we will be very conscientious to continue to test on real physical nodes with real physical InfiniBand continuously throughout the the release and development process. So that's the first one. The next one is something that Eric Barton has been, he's not here, is he, whittering on about for years, which is stutter testing. So one of the issues that we're all aware of is that modern CPUs don't have a clock speed really. They list a clock speed, but the reality is the thing is dynamically changing its clock all the time. In fact, the calls will often run above their listed clock speed. And therefore, when you have actually on your laptop as well, but any size cluster, different calls are going to be running at different speeds, different CPUs are going to be running at different speeds. And that means that it brings out a lot of race conditions as this becomes more and more, extreme, I guess. It brings out race conditions that are quite difficult to capture. So Oleg, 2 mentions for Oleg. Oleg realized actually that this was really easy to simulate and that we could do it just by setting up more cores in the VMs than we had real cores in the system. In actual fact, originally we were quite careful to make the number of virtual cores less than or equal to the real cores. So now what we're able to do, that's a thing. Now what we're able to do is, knock me off my stride. Now what we're able to do is to dynamically change the number of cores between tests. So we obviously can't do it dynamically in the tests, but we actually can configure different cores, and we can go from where we were, which is very repeatable testing, to what I call all over the place, which is where we probably have as many cores per VM as there are real cores. So therefore, we're on a 16 VM machine. We've got 16 times as many virtual cores, and we have brought out some very interesting bugs with that. So another thing that has been running for a while is upgrade, downgrade, and interop testing. And basically, as part of the release cycle, I mean, what we can do is test any compatible version with any compatible version. And the standard test matrix that we run means that we test the whole matrix for every release. In actual fact, we test most of the matrix for every push to head. So every time we push to head, in fact, to be quite honest, 2 pushes to head will have tested the whole matrix, because we test half of the test matrix for every push to head, except when we do release candidates, and then we do obviously more than the whole matrix, if that's possible. And the other thing that and what we've kind of extended that in a way, so we can now do the upgrade path matrix. So we can upgrade from any version to any version, that should work. We could do the ones that don't work. But, and we can go up, we can do upgrade testing and downgrade testing, and we can update, as part of the automatic system, we can upgrade just the servers, and we can go down. And this means that, and the other thing, as I said, because it's, because we've got a bunch of components, all of the features can be tested as part of interop. So we can do interop, with failover, or upgrade, downgrade testing on failover systems, and all sorts of, as much as we can think of, really. And as I said, the matrix that we're able, the trouble is it increases the matrix that we're able to test, right? And that's kind of, increasing the requirement for test hardware. So that thing on the bottom is because we have actually run 1.8 all the way through to 2.4, and then all the way back to 1.8 as part of a test, although we're doing it in a slightly different way now, but we're able to do that. So 2 more slides, I should be in time. We developer test. Now, I spoke about developer test last year, and it was one of my real goals was to get it more widely used. And just to recap, as part of as a commit, you can actually, and if you can see that, you can probably see that, you can actually put a line test parameters in your commit message, and then you can specify, you can make use of all the components. So in this case, Eugean specifies she wants quota enabled, and she wants slow running. But you can actually say, and I want 50 virtual calls per VM, or any of the things that I've talked about, you can actually access through this test parameters facility. And if you Google test parameters in commit message, the wiki page is the top hit, by the way, which is my only ever top hit on Google. So in the last year, we've been running at about 1 a day. I did this in February, I think. In the month before that, it was 6 a day. Most of it is debug. Most of it's debug. I would really like to see more of it being part of development rather than just part of fault finding. But hopefully that's an exponential curve that's just about to go off like a hockey stick. But we're definitely seeing more and more of that testing. So, final slide. We have, as I said, we have, and I've always spoken about the kind of bar, the standard that we require you to get to, all of us to get to, before we can land a change. And that's kind of called review. I call it review, and it often people say, what are you talking about? But we have that bar, we never lower the bar, and in actual fact, Peter's lost a lot of nights because it now works that if the test system breaks, nothing lands. There's no exceptions, we don't make exceptions. So we have a minimum standard that we always live up to. What we're now able to do, and because we've at times got more capacity than we need, is the test system, if it's quiet, will just do additional testing. We have about 14 suites, I think, at the moment in review. We can do another 8 suites, or we can test it with a different file system, or we can test it with a different network, and all sorts of things. So the key thing is, if we can, we will lift the bar. And although the testing is optional, whether it happens, because it's whether the test system will do it, you do have to pass it. So if you're unlucky and you get it on a quiet day, you have to do better. Not sure what that means, but I'm about to get my kneecapped. So I'm not going to tell you where we're going, but I'm happy to tell you where we're going, and if I have time, take any questions.
We have time for perhaps one question.
Ask a question. No, I can't, because I'm about to get beaten up and sent off.
So I think we may be the two people who have had the Mellanox release candidate. I was actually, we did testing with a virtual cluster using SRIOV, and we were actually really surprised at how well the virtualized InfiniBand adapter worked in terms of both latency and bandwidth. So I'm wondering, are your reservations based on just because it's new, or do you actually have reasons to make me be suspicious?
No, I don't have, my reservations are just that when we only do testing on virtual InfiniBand and we release Lustre and it doesn't work on real InfiniBand, we'll look really dumb. That's my reservation. I just think it's worth checking. And I bet 95% of tests will end up on virtual InfiniBand. It's just a check. It's just to check that, you know, there's not some obscure thing. And I thought you were going to tell me that we've tried it and it's really bad. So that's good news. Okay?
So when you say testing, it just really means accepting small testing?
Yeah. Oh, it's more than that.
Well, we have like a very extensive test suite, and like we have basically more tests. After you go into Jira, well, in Gerrit actually, there's a link and you can see various things that are actually tested, and you can request more of them added using that test scripts functionality that Chris mentioned if you want to include even more of that. In addition, there are like different file systems that we are enabling and stuff like that. So I don't think it's quite at the level of acceptance small. It runs more stuff.
So my answer to you, which was obviously, we are running all of the scripts that are in the Lustre test. That's test for us is the test that form the Lustre source. And if you look in Maloo, you can see exactly which scripts we're running at any given time. Okay. Thank you.
Thank you.